McKinley, can you confirm my screen's being shared?
Yep.
Okay. Well, I'm going to go ahead and get started, and I am going to show you where we are this week. November 3rd, we have an assignment coming due on Tuesday, and I've gotten a few questions from students about having trouble with some specific questions. In particular, reading the maps about the upper level westerlies with question 8 and 9. McKinley, can you just give me any firsthand experience? Is the lab fairly understandable, or would it be good to go over a couple of questions on that assignment?
I've done like part of it.
So it wouldn't hurt to go over and clarify what I want.
Yeah, I think you could go over. I think that would be a lot helpful for us.
Okay, so what I'm going to do is I'm going to show you there's assignment that's coming due on Tuesday, and then there's assignment that is becoming released on Tuesday. And I think the two are actually interwoven. I specifically had a very good question from a student who's incredibly busy, and she sent me some questions about specifically how to read upper level weather maps. And so I want to kind of go, and I'm going to make this available to you today. I want to make sure that this assignment is available to you now. I don't know for sure if you could see it, but global circulation model. I just want to make sure when it's available. Let's see, edit. And this assignment actually helps understand the assignment that's kind of coming due today. It's available tomorrow, but I'm going to make it available now. I actually have a sample post on there that will help the student. So when I go over it, I'm going to first show you, this is the assignment that's coming due.
So the one that's due Friday will help us understand the one that's due tomorrow, correct?
Yeah. And in
Okay,
particular,
perfect.
the one I posted a sample video. I was aware that some of the stuff we're talking about, and I'm going to show you, the assignment that you guys are working on is this one right here. Okay? Correct?
Yes.
Okay. And I even went into there and anticipating over the semesters I've taught it, I've actually added a video here that I really think helps you understand how to read the westerly winds and whether the air is moving straight west to east zonally, or if it's flowing more north-south meridionally. What would cause like temperatures in the Midwest to rapidly change has everything to do with wind directions. And if you're a sports person and you play outside, you know darn well that a wind coming out of the north feels very differently than a wind coming out of the south. Is that fair?
Yes, that is fair.
Especially when you have a baseball field orientated north and south at Lakeland. It's not just how it affects how the ball moves in with or against the wind. It affects the temperature. And in the video here that I posted, I found this lady, and she just does, and I take some grief, and I take some grief from some teachers. And students, I think I use YouTube videos too much. I just think they're so much better than the textbook, because the textbook often doesn't show animations and things three-dimensionally. And having somebody orientate. The map she is showing you is the 500 millibar chart, and she's actually showing you what causes the winds to change direction, whether or not you see these lines, these pressure lines moving to the south or pushing to the north, or whether they tend to run straight. And that's what you're kind of looking at in the assignment you're working on with the last two questions. they kind of are loaded with, like, I think they're worth 8 of the 20 points on the assignment are questions 8 and 9. So I could really appreciate it. It was a good question by this student. I actually posted a video literally going through last week how to go through each one, but I was a little vague on questions 8 and 9 about explaining the details about what is a trough and a ridge, what is zonal versus meridional. And so this assignment here, actually, and now I'm backing up, is this is the assignment that I just made available to you. And I'm almost starting to prep you guys to think about a Unit 3 exam and you guys producing your own study guide, all right? I basically am requiring you to pick one of these topics. And do you like a fastball down the middle, McKinley, and you know the pitch is coming down the middle? Would you like to know before it was pitched?
Yes.
That would take all the risk out of it if you knew what the pitch was and where, correct?
Mm-hmm.
This assignment is like a fastball down the middle. This is a 20 out of 20 for you. If you, because I'm basically paying you 20 points to basically prepare an interactive multimedia review for yourselves. And it's as good as you guys take it. And in fact, some of you, I think, will be teaching and doing work and interacting with people in business and whatever careers you go out in a very similar way. These are 8 topics that you are going to see on the test, right? Now, on the assignment that you're working on, I am beating you to death on that topic, those 2 topics there. I am really hitting you hard on topic 7. And I'm really teaching you how can you read a map of isobars and pressure changes and understand how winds are moving. So the assignment that you're working on is really hitting 4 of the 8 topics very hard, all right? And all you have to do is take the topic that you want to learn about. Now, by the way, I went down here and I already did one for you. And the request I had was, Mike, I don't understand how to do question 8. I don't know how to read these darn maps about the 500 millibar chart with ridges and troughs. What is a zonal airflow pattern versus a meridional? Now, if you ever manage or work outside in construction, or you work in marketing and business where something is based on sales with weather, like at Home Depot, or you sell food products, I can guarantee you certain coffee drinks and lines are very seasonal based upon temperatures. Or if you play sports, for that matter, and you're constantly dealing with disruptions. You don't have any disruptions in weather, McKinley, do you, in the spring schedule with softball?
We do.
It's a joke. I mean, it's almost
Yeah.
comical of when you start spring sports in March. Technically, you're still in winter, and I would say the first 2 or 3 weeks of the semester, you have a 50-50 chance of many games being disrupted, canceled, or heavily changed or modified because of the weather conditions.
Last year, our first weekend, we were supposed to go to Alabama, and that one had to get canceled because it was just too cold down there, and it was rainy and all that.
So what you're talking about is, do you see the picture I have up here?
Yes.
Okay.
Lower. It's 15 here minus.
What killed you, McKinley, is this is the weather map that killed you when you were in Alabama, correct?
Yes.
This is zonal airflow, and this is what cold air from Canada driving south into a trough looks like, and there is a massive ridge. On this day, warm tropical air is buckling over the south, and she will explain it to you, and this is what meridional airflow is. On this day, the 500 millibar heights are elevating and going to higher altitudes in the west, which would actually produce unusually warm, dry conditions, and then out west, that often means wildfires, okay? Out east, when you see the exact opposite, is when we see cold air penetrating deep into the south, bringing cold conditions, and that causes the 500 millibar heights to lower, okay? And she ends up showing you a picture like this. And she shows you that on days when the air is pushing out of the north, it causes the 500 millibar heights to lower into a trough. And that's why in Alabama, when you're in March, sometimes you think it should be warm and in the 60s and 70s. But on the days you're there, if the jet stream and the westerlies buckle into a trough, the weather in Alabama is going to feel more like Michigan and Minnesota. And that's the weather in the westerlies. Whether the westerlies move north and south or west to east determines how predictable the weather is or is not going to be. And so on questions 8 and 9 on the test, I really probe you understanding what's happened. And I'm going to pop it up here, but I'm just kind of giving you a clue. If you go into the Global Circulation Model Review, I have already posted a video on here that really explains what's going on and what creates troughs and ridges. And basically, I'll just tell you, if I'm a softball or baseball person or golfer in March and April, a trough is my nightmare. That's when the weather does not perform unusually cold. It actually is unusually warm. It's when we get unusually cold weather because our weather tends to behave more like it's from Canada. When we're in a ridge, we get more weather associated like we would see coming out of Texas and the Southwest, where it would be unusually warm. So that's the overall, the very first sample video I posted here is, this is how I would do it, is you just take the topic. So obviously I've done this one, but I could promise you, understanding weather with high and low pressure systems, high and low pressure systems are called cyclones and anticyclones. I would copy that topic. I'm going to stop the share, and I'm just showing you how to do this one now. I'm going to go to YouTube. Are you seeing this, McKinley? Did it pop up?
Yeah, I did.
Okay. I would go cyclones, anticyclones. You see, I just copy and paste it and I just post it in there. And I start looking and reviewing. And kind of look at my book, and you start going down into here and you start looking for what are some, oh, I really like this. This looks good. I like this one. I mouse over it and I see, and I know enough about, oh gosh, I got to show this in class today. I'm going to show that. So let's say you see this one here.
An anticyclone is a weather phenomenon.
This is really good, by the way, but the problem is it's showing you an anticyclone in the northern hemisphere and in the southern hemisphere. This is kind of good. This is the way any arrow should be drawn if you're labeling a high in the northern hemisphere for a surface high, okay? And you could also show you what the air is doing around a high pressure cell. It's sinking, all right? And so I think you'll end up seeing them showing a low. I think this will move into a low.
Hence, in winter, in fair weather, which suppress, in contrast to the cloud.
So in this video, all of this video is about high pressure systems. They don't go into doing both, but since we have so many students in class, let's just say you go, well, I really like, because they go into depth of showing what high pressure systems look like. And I like the fact that he shows what it looks like on a weather map. And then I actually like what it looks like if you were to actually be under a high, the kind of weather associated with it. Does that look like bad weather or nice weather to you, McKinley?
I would say bad.
Bad? Do you see a cloud in the sky? Do you see a lot of sunshine with that boat?
Yeah, no.
So,
I don't see clouds.
I don't see any clouds. Do you see a lot of big wind producing big waves around that steamship?
No, I don't.
That looks like good softball weather to me.
Yeah.
High pressure systems tend to produce calm, clear skies. Well, what kind of weather do you like to play in?
Calm weather.
Okay,
Definitely.
There you go. If I showed you a low pressure system, it would be very different. It would be cloudy, windy, and you often have very cold conditions. Does that make sense?
Yeah, that does.
Okay, so you watch this video and you say, yeah, I think this is going to be very good. And they're obviously explaining why do mariners like high pressure systems? They tend to produce calm conditions with weak winds, and that makes traveling on the water much easier. Does that make sense? So mariners like to find, just like sports people outside, high pressure systems tend to make navigation much easier. Does that make sense?
Yes, it does.
Okay, so you say, I think this will be helpful for me, not just me, but for the class. You say, oh, okay, I'm going to use this one. I like this video. I'm going to copy it. Okay. Hit the copy button. I'll stop my share, and I'll go back in and go back into the assignment. Is your class back up? Back up, right? The discussion board?
Yeah, now it is.
Okay. So when you explain a cyclone or an anticyclone, I want you to be able to answer, how does the air move vertically and horizontally? Is it sinking? Is it rising? And is the air being pulled in or is it being pushed out? Okay. When you watch that video, it should be made, and by the way, in this one, it's really talking about a high pressure system, which is an anticyclone. So you click reply, and you click insert, and just click embed, right click there, and you can paste, click submit. And you see how that video from YouTube's there? And then you just type your summary right next to it or above it. Does that make sense?
Yes, it does.
And so you could do a lot of athletes and a lot of people in business and TikTok and Instagram. You've seen a lot of young people and they end up, like somebody does an amateur cooking video or something like that, right? You can embed, this is how you embed somebody else's video that you want to use in your stream, so to speak. And so I want you to stay in Canvas. So I want to be able to read I want you to be able to watch my video from this expert here and read my summary. This proves I watched this video because I am teaching you guys what are the key themes that she's covering in this 9 minutes. My video is a bit long. I would like you guys to kind of pick anything between 2 to 5 because people are more likely to watch it, all right? So I think you have to watch post one video and you have to review 4 other students' videos on here. So you'll comment it. It isn't like you're getting 20 points for doing it, 10 points for posting the video, and 4 points for reviewing. I would argue all of you should go look at my video right now because it actually helps you answer the assignment that you're doing right now. So I'm going to go to that assignment right now, reading air pressure maps, because I got an email from a student that says, I just don't get it. How to read an upper level pressure map. That's what this video does, and that's what my summary does. Does that make sense?
Yes, it does.
Okay, so now I'm going to go show you that assignment, the one that you guys are locked in on, and it's due tomorrow, right?
Yes.
Okay, now I'm going to open it up. And I'm not going to spend much time on the easier ones up at the front. I did that last week. The quicker somebody could post a video, how to label a map of isobars, McKinley, that would be great. There are great videos. How do I draw arrows around a surface weather map of highs and lows, right? And it would be very nice to have a video posted today so people could see to make sure that they are drawing their arrows correctly around a high and low pressure system in the Northern Hemisphere, okay? I'm just giving you a hint.
Okay.
Question 8. Here are the westerlies, all right? These lines are telling you how the winds are moving at the 500 millibar height. This shows you the altitude, and I'm going to zoom in. Did you zoom in at all? Are you zoomed in on the map?
Yes, you are.
The tail is telling you the direction that the westerlies are moving over the United States. The end of the tail where the dot is an indicator, and if you look, they're almost all pushing west to east. Do you see that? They start to turn to the north just on the eastern coastline right here, like at New York and Pennsylvania. Do you see right here?
Yeah, I do.
This is what zonal airflow looks like. And what's happening is when the airflow moves zonally, it's kind of keeping the warmest air where it should be, which is where? To the south. And it's keeping the coldest air where it should be, which is where? To the north. When the weather's moving like this, the weather is fairly consistently where it should be. If you look on the map on the next day, what changed, McKinley, is are the lines moving west to east, or do you see more of a roller coaster?
More of a roller coaster.
And that's trouble for you if you live in the middle of the United States, in Illinois, and you want to play softball or baseball or golf or whatever, you know, or construction, for that matter. Is now what's happening is you are seeing the 500 millibar height changes when cold and warm air are beginning to move. When Canadian air moves, it causes the 500 millibar height to lower and compress. And that's what you're seeing here in the middle of the country. On the east and west coast, do you see how the lines are bending to the north?
Yes.
That's because warm air is driving to the north, and then we call these ridges, okay? And that's why I want you to watch the videos I pointed you out earlier. They really go into explaining this. So the weather changed so dramatically from this day to this day because effectively on the day before, the wet jet stream and the westerlies were going west to east. Now they're going west to east, but they're going in big loops north and south, and they're mixing cold and warm air in troughs and ridges. And so effectively what's happening is on this date, much of the middle of the country, the weather is actually behaving more like it's out of Canada. And that's why it's possible you could go on a road trip, and if you're in a trough and you're down in Arkansas or you're down in Texas, even though you went that far south, the cold air from Canada followed you all the way there, and you basically traveled south for nothing. Does that make sense?
Yes, that does.
So, and that's what happened to you last year, it sounds like, correct?
Yes, definitely.
And so there's nothing worse than when you're in Illinois or Indiana and Ohio, and you go on spring break, and you're down in Jacksonville or down in the Panhandle area in Panama City, and if a trough works its way over Florida in March, even though you're much further to the south, it could be in northern Florida in the 50s and 40s. If a trough comes down there, that's why you have to look at the weather. And so I'll kind of help you on a couple of the questions here. What is the 500 millibar height in Brownsville, Texas? The 500 millibar height, you have to know how to read the station models, okay? The top right number is the altitude of where the 500 millibar, and it's dropped to 0, okay? So this is in thousands, and so this is not 571 meters. This is 5,710, okay? So the first part of this is you first have to know, I guess, where is Brownsville, Texas? Now, I know Brownsville, Texas is in southern Texas, all right? Now, you'll have to Google that. And many of you, if you don't know where Brownsville, Texas is, you could find out quickly, right? I mean, you could Google it and find out it's in southern Texas. This is the reading for Brownsville, Texas. So what would that reading be? It's not 584. It's 5,800 and... McKinley, what's the height?
20? 5,000, is it?
584. All you got to do is add a 0.
Okay, so 5,800, 140. Okay.
Correct. And if you look at these lines, these baselines have already been labeled, and they give away that they're in thousands. Do you see that?
Yeah. Okay.
They are labeled. Now, if you'll notice, as you go to the north, you go from 5820, you go to 5,700, 5580, 5460, 5340. What's happening as I go this way, these lines are they getting higher or closer to the ground? They're 5,800 meters here, and as I go to the north, they're 5,500, you get to 5,400, 5,300. You can kind of see that as I'm going this way, the 500 millibar, these lines are not going up. They're actually getting closer to the ground because as I go this way, the air is getting colder, and colder air compresses and warmer air expands. So the warmer down here is at a higher height because it's expanding, and the air, if this was like a slide, these lines would be higher, and these lines up here would be lower, and the air would want to slide this way from south to north. Now,
Okay.
the reason why they don't slide, why are these lines though? The wind's going this way to the east. Do you see that?
Yeah.
And what force takes air and like this should be like a fastball, right? But depending upon the spin you could put on the ball, you can make it turn, right? What does the Earth do? It rotates. And we know from the chapter 4 and 8 that when winds start to move across the pressure gradient, the air can be deflected to the right. And
Yeah.
so if you look at this diagram, the winds are actually going to start out of the south, and they're going to turn and bend to their right. And that's because of the Coriolis deflection. And that's why all of these winds are like a machine moving from west to east. So this is the pressure gradient and the Coriolis force coming together. And this is why when you're in Illinois, if you want to fly to California, you're flying into the wind. But if you're flying from California and going to New York, usually the winds are doing what to an airplane? They're pushing the wind. So it's actually quicker to go from California to New York because the winds are often pushing you. But when you're going from the east to the west, airplanes are actually flying into the wind. So why are we interested in our weather in Illinois? Why do I like to look at the weather in Missouri and Iowa and Nebraska and Kansas? The weather over in here is heading right towards who? Us. I'm not as interested in the weather in Indiana. You know why? Because the weather in Indiana has already passed, and it's now going into Ohio. So when we're in Illinois, when we're looking at tornado and severe weather, we like to look at Missouri and Iowa and Kansas and Oklahoma because the weather in these states is the weather heading towards us. Does that make sense?
Yes, that does.
The 500 millibar height in northern Michigan. Well, here's Michigan, there's northern Michigan, so you could read that number now, correct?
Yeah, so we just add a 0 to it, right? And then it's 5,470.
Yep. And because this air is colder and the air down here is warmer, this air is expanding and this air is compressing, and that's what's creating all this wind to move.
Okay.
So I think I've just answered this question just now, by the way. If you were following along,
Yes.
I answered both these questions. Okay? Now, I'm going to leave question 9 because I think I've set you up. What type of upper atmospheric flow is lowering the 500 millibar height over the central United States? What you're basically seeing is you can see the lines are bending out of Canada right over the middle of the United States, correct?
Yes.
That is a bad sign because when you see lines like that, that means the weather and air in Canada has moved into our part of the world, and our temperatures and weather are going to behave more like that part, more like Canada. Does that make sense?
Yeah, so it's
There's
coming
a
to
mix-
us, basically.
And so there's words like ridges and troughs, right? And you got to use the correct one. What would cause the 500 millibar heights to lower? What would cause the 500 millibar height to lower?
Isn't it getting
from-
closer to the ground?
Yes, that's what I mean. Why would that? What kind of air would cause the 500 millibar height to lower? And you remember that video I had up with that lady where she showed you that line between two
Yeah.
columns of air? She walks you right through it. On this date, would it be warmer on the east and west coast, last question, or in the middle of the country? So if I was to go in Virginia, and if I was to go into Illinois, and I was to go into California, these are all locations at the same latitude, correct?
Yeah.
On this date, they're getting the same sun angle and same length of day. I would want you to answer then though, on this date, would you think the weather in Virginia and California would be warmer or colder than the air in Illinois if this was the setup on this date? And you could see, you should be able to answer that because on this date, the weather is not very predictable. It's very unusual because we're getting, the westerlies are moving north and south and we're mixing cold and warm air. Some places are above average and getting higher temperatures. Some places are below average, correct?
Yes.
Is the middle of the country above or below average? I'm just curious. What do you think, McKinley? But when you see airflow like this, where would you rather be, along the coast or in the middle of the country if we're after warmer air?
I would want to say in the middle, it looks like.
Is the middle warmer?
Sorry.
The air in the middle.
No, it looks like it's warmer out on the coasts.
And so you just got to tell me what these terms are. What are the terms that describe when we see these kind of features, where we see the jet stream and the westerlies moving in these sort of like roller coaster patterns, like you're going up and down hills?
Yeah. Okay.
I think that should help you guys get through the hardest parts of questions 8 and 9. And that's 8 of the 20 points are on those two questions. Does that make
Okay.
sense?
Yeah.
I think that should help you.
Yeah, it did.
Okay, good. So those are the 2 assignments this week. Please post on the Global Circulation Model discussion board. I made it available a day early, and I will get back to you guys shortly, okay?
All right.
If
Thank
have
you.
All righty, I'll let you go. I'll get this posted.